start looking at the definitions of parts of the circle. So if we remember, the radius was from the centre to the outside edge. Okay? And we normally label that with R. So you should have had a description, the distance from the centre to the outside edge. What's the diameter? The diameter. Not the outside. Remember, that's a special name that comes a bit later. I mean,
It's from one end of the circle right through the middle of the other.
awesome. So it's from one side of the circle all the way through, but it has to go through the centre of the circle. Okay? So the diameter is the distance from one side of the circle to the other. I'm going to put in capitals through the centre. Now, I appreciate that I don't know that those dots are actually in the middle of that circle, so I do apologise. They're not great, but it gives you an idea. Okay, so the diameter is the distance from one side of the circle through to the other through the centre. Now, we label the radius R. What letter do you think we're going to label the diameter? D. No prizes for that one. Okay, so we've got the radius and we've got the diameter. Now, chord. So it says chord, not chord. It's not a usual chord, it's a mathematical chord. Does anyone know what a chord is? Would you? Pardon, Dennis? What did you say? It's not a curve, no. No. Sarah?
Two lines go into the middle.
Not two lines, no.
And the set is not on the
Nope. So a chord is a line that goes from one side of the circle to another.
not.
But it doesn't have to go through the centre. Okay, so a chord is a line, or a line from one side of the circle to the other. So it's a line that cuts the circle up. Now, you may notice that that description is very similar to the diameter, yes? So the diameter is actually a special chord. Okay, so the diameter is a special chord because it is actually the longest chord. Because if we've got a line going from one side to the other, if it goes through the centre, it means it's the longest possible chord. Okay, so the diameter is a chord. Not all chords are diameters though. Okay, so make sure you're happy with that description. Chord we don't label with any specific letter, it's just the radius and the diameter. Okay, so radius, diameter. Pardon?
I labeled it with the C.
Alright, so that's chord. So the diameter is a special chord, it's the longest chord. Okay? Tangent. Does anyone know what tangent is? No? It's probably a brand new word to most of you. It's a straight line that just touches, oh, that wasn't a very good one. It just touches the circle edge. Okay, so ideally you perhaps drawing this with a ruler. It could be anywhere though. So you can draw it here or here, wherever you like. It's a straight line. A straight line that just touches the circle edge. Okay, so it just touches it. The circumference, we talked about that last lesson, didn't we, when we were measuring. What's the circumference?
Outside.
The outside of it. Bless you. Now, bless you. I've actually done that one for you. I put it in bold, and so hopefully you can see that. So it's the distance around the outside. And what do we normally call the distance around the outside of the shape? How do we normally describe that? The perimeter. So it's the perimeter. I'm going to put that in brackets because we would normally, when we're talking about a circle, we would say find the circumference. We wouldn't generally say find the perimeter. Okay? But the circumference is the distance around the outside of the perimeter. And we'll come to the formula for that in a second. So there's a special formula for that. Oh, an arc. What do we think an arc is?
Maybe like
Half of what?
the circle.
Not half of the circle,
Or
no.
like I don't want to say
Try and use it using words that we've already had. So
half of the
I'm loving it. It doesn't have to be half though. It's just part of the circumference. Okay? So an arc is any part of the circumference. Okay? So that little bit right there would be an arc. So the circumference, so an arc is part of the circumference. Good going, Brendo. That was well using the other words to help describe it. Because remember, it is tricky in maths, isn't it? Often you perhaps know what you're doing. It's quite hard to get that description in words to other people to make sure that they're understanding. Have you used it for that reason? So an arc is part of the circumference. Now, I've just drawn a tiny little bit of an arc. Could be as big as you like. Okay, that could be an arc. Okay, so it doesn't have to be a tiny piece of the circumference. It could be as much of it as you wish. Okay, but it's a part of it.
Can I highlight with my pencil?
You can do it. Like that, your notes, sweetheart, remember? So sector and segment. Now these two are ones that people often just get mixed up. And because they both begin with an S, they're too similar for a lot of people. So a sector and a segment. So a sector is a piece of pie. Okay? A sector is a piece of pie. Okay, so it's a piece of pie. So it is formed with two radii. Notice that if you have more than one radius, it's radii. So these two lengths here are my these two are my radii. And then what was this bit? This bit here would be an arc. Yes. So it's formed with two radii. That's the blue bit. And an arc. That's the green bit. Okay, so it's a piece of pie. So it's formed with two radii. So it has to go to the centre. And an arc. And it's that shaded part. Okay, so it's the bit that we've actually shaded. A segment is also part of the shape, but it's what was this line called? Chord. Good. So this is a piece of the circle.
Is it formed with a chord because it has an arc?
It is formed with a chord and an arc. I'm gonna piece of the circle, so it's a chunk of the circle, and with a chord, which I did in black, and an arc, I'm going to do in green again. Okay, so it's this shaded bit here. So it's a piece of the circle formed with a chord and an arc. Now, sometimes people remember this segment because that bit there kind of looks like a piece from an orange, doesn't it? Yeah. And we often call those segments, don't we? So we could perhaps remember those ones because it's like an orange segment, and then therefore the other one has to be the piece of pie.
But the other one looks like an orange segment from the top.
Well, yeah, you don't want to make yourself difficult for yourself. Try and make it easier. So, well, I think this one looks a little bit like a piece from an orange, no?
Yeah.
I mean, maybe not. That's what I think. So that one's a segment, and the other one is a sector. Okay? Now, we are going to perhaps use some of these words, maybe not all of them, but some of them as we progress through this first work. Okay? So, just be aware of that. Remember, I'm not a big flashcard girl. The maths, I don't think is necessarily the way forward to helping you, but the certain things, it's great to help you remember words and phrases. So to help remember these, you perhaps would like to do some flashcards with a picture of a sector and then a description on the back, and there you can learn how those go. Okay, so as I say, with math, not always useful because you often get given some formulae that you need, but terminology is very important that you understand what these things are.
What is that? What's the one above a chord?
Circle. Piece of the circle. Okay, so it's a piece of the circle. Now, whilst a little pit stop, you're not going to like it. Test date. Okay. Oh! So the test is going to be, so you need to get your planners out. I know it. Test is going to be tomorrow. No. Kidding. I'm such a trickster. Alright, so pi. We talked about pi last lesson, didn't we? We did that little activity where we discovered that. Who can tell me, what did we discover? Jade?
So when we take the circumference of what we're measuring, and then we divide it by the diameter, then it will give us a very close number to pi.
Awesome. So do you all remember that?
Yeah.
So when we have the circumference, we divide it by the diameter, we get pi. Okay, so pi is used to calculate the circumference and area of any circle. So when we're asked about the circumference and area of a circle, we're going to be using this fancy number pi. Pardon? It's just kind of two lines and then a squiggly thing on the top.
Yeah, for Spanish. For Spanish, no.
Okay, so two lines and then a squiggle on the top. Now, the circumference divided by the diameter would equal pi. Now, do you remember when we did some rearranging of it? Or have we done rearranging of things? If you've got something divided by something and you want to just have circumference, how do we get rid of this diameter? Do you remember this from year 7?
No. So you have to take the pi. You have to take the pi and divide it by the diameter.
No, it's divided by diameter. But so if this something here is being divided by the diameter here, if we want to get rid of this, we want to remove it, we have to do the opposite thing to it. Okay? So if it's being divided, then we're going to have to multiply by the diameter. Okay? Now, it means that if we multiply this side by the diameter, it's gone. Okay? But we can't just do one thing to one side, we have to do the same thing to the other. So what happens is that my formula now becomes pi multiplied by diameter. So this is what we call rearranging equations. So because the circumference divided by the diameter was equal to pi, then if we wanted to find the circumference, we would need to know pi, which we obviously know it's always the same, and we would multiply that by the diameter. Okay, so our formula, which you will often see, is C equals pi, what did we say the diameter was known as? D. So C equals pi D.
Oh yeah, because
Okay, so big C equals pi D. So this is why we didn't call the chord a C, have you? Are you writing the notes, sweetheart? No, you're not writing to that. So which camera or wait? You can do that later. So circumference equals pi multiplied by diameter. But going back to this picture here, is there a relationship between these two? Oh, what was the radius? radius? The radius was from
The
the
middle
the middle to the outside. What was the diameter?
From the middle circle to the outside.
But it's all the way through the
Well, this was all the way through, wasn't it?
So
So,
radius.
it should have. Is there? Yes. So, both m squared and j have recognised it. If this is from the centre to the outside, and this is all the way, then this diameter must be equal to 2 lots of the radius. Yes? Make sense?
Why did you just
Because we can do this, radius, radius. Well, it's the same thing, isn't it? So 2 lots of the radius must be equal to the diameter. So if we're trying to find the radius, and we do the diameter, what would I do to it? Divide it by 2, yes? So if I knew that the diameter was 10 and I needed to know the radius for some reason, it would be half of 10, which is 5. Okay? So, I just made that up. I said if the diameter was 10, then the radius would be 5. If the diameter was 20, the radius would be...
So they're just using a number.
Yes, they give you
So
some.
for this,
So, yeah, we're going to come to this in a second. So here, we know that the diameter is equal to 2 lots of the radius. So that means that I could say that the circumference was equal to pi multiplied by 2r. So all I've done here, Maya, is switch this from being a d to 2 radius. So if the circumference is equal to pi times diameter, then it must also be equal to pi times 2 times radius. Yes?
I can put it down something.
It's a tiny multiplication. Now, in algebra, we normally put things in a different order, don't we? Which order does it normally come in? What order would I usually put things in? What normally comes first? Numbers. Okay, so I wouldn't normally have these 2 smack bang in the middle. It would normally be at the front. And then pi is actually a number, so that would come next. And then r is at the end. So, underneath, circumference equals, well, just because 2 is a more obvious number, but whilst pi, it represents a number, it's still a symbol, so we would normally write. Now, you don't have to write it like this, it's just that that's how we normally remember it, okay? So, with the circumference, yes, okay, where am I lost to? The beginning of what? Alright, so we found the other day that the circumference divided by the diameter gave us that number pi. Do you remember we had all these measurements we had on the board? Yes, you remember that? So what I want to do is say, well, okay, a lot of the time I'm not going to have a tape measure to measure around, because we need an actual tape measure. Yes? But I could probably use a ruler to measure the diameter of something. So is there a way of me finding the circumference of something by using the other 2 pieces of information? So what I've done here is I've rearranged this. Now we'll do more rearranging later. Okay? But for the now, if you have something divided by an amount, to undo that or to get rid of the thing or get it on its own, we're going to have to do the opposite thing. And that means that I would have to multiply by the diameter. Because if I multiply that by the diameter, it means that these 2 things will be cancelled out. Do you remember like the fraction? Yes? But I can't just multiply this side by the diameter. I have to multiply this side as well. Okay? So because I've been able to cross those out, because it's on the top and the bottom, my new formula says circumference equals pi multiplied by diameter. Okay? So C equals pi d is one of my formula that I can use to find the circumference. Okay? We've then gone on to recognise that the diameter is the same length as two lots of radius. Remember, so just now, that's radius from the centre to the outside. So the diameter must be two lots of the radius, mustn't it?
Oh, yeah.
Yeah? You see that now? So that means instead of writing the letter D for diameter, I can write 2R, because that's the same. Yeah? And then all I've done here is rearrange the order. Alright? So we've got circumference equals 2 pi r, or circumference equals pi d. Both of these two are legitimate formulas.
Wouldn't it be pi divided by the diameter? Because don't you need times the diameter by the circumference to get pi?
No, to get pi, we do the circumference divided by the diameter. Remember we did the circumference divided by the diameter. Okay. Right, so here's some examples. Now, I think we're going to give you these formulae when you're doing them, so you don't have to learn them as yet. Okay, so we'll give you these formulae. So we just need to know how to use them. So it says, find the circumference of the following circle. So the question we have to always ask ourselves is, have we been given the radius, in which case we would use this formula, or have we been given the diameter, in which case we would use this formula? So they're the two things that you have to ask yourself. In my first question here, have I been given the radius or the diameter? The radius. So that means that I'm going to use that first one. So the circumference equals, well, which one? Which one is it? 2 multiplied by pi multiplied by the radius. So what is the radius? 5. You see what I did?
No. Wait, oh yeah.
Well, hang on a minute. I think people say no without actually considering what I've done. So my formula with here, 2 pi r or pi d. We established that this measurement here is the radius. So that means we have to use the red one. So I just stuck, instead of the letter r, what did I put in? The number 5.
We know what the radius is.
Because we've been told what the radius is. Yes?
So you only replace
Higher.
Oh yeah.
Yes? Do you remember? Yes? What were you saying?
The number, I mean with the
Exactly. Do you remember when algebra? Yeah, exactly. That was when we were doing substitution. That's exactly what we're doing. And we don't have to ever replace the pi because that's always the same. Yes, that is a number. So the only thing we had to replace, the only thing we substituted is that right here is the value of r.
But is that what radius 1 or 1 r?
No, darling, it's 5 centimeters long. The radius is always just a line from the centre to the outside edge.
Yeah, you said because of the diameter, how it is 2.
Yeah.
It's never going to be 1 radius.
Yep. So when it's the radius, we use this one, this formula, 2 times the pi times the radius. And when it's the diameter, we just do pi times the diameter. Okay? So we're going to have to put this in our calcs. We need to make sure we found the pi button. And do you remember where that was?
No,
Yes.
you have
Oh, so they've got, the calculator will tell you initially 10 pi. How do you think they got that? Am I going to tell that person? 2 times 5 and then it's pi, yes? So that makes sense. But this isn't the normal way that we would leave something. We would normally round it as a decimal. So how do we find decimals once we've got this? What did we trust to be the S? The S or D? Yeah, the ST button. So press the ST button and what do we get?
31.41.
Okay, let's round it to 3 significant figures. Now, what do you think my unit's going to be for this one? Centimeters, yeah. And you said that higher why? Because it was 5 centimeters to start with, yes? Now, it's a perimeter of the shape, the outside of the shape, which is a distance, so we just keep it a centimeter. The formula, sweetheart, it would be 2 pi r. That's our formula that we'll use. 2 pi r.
2 radius is 1 circle.
2. It's just the number 2.
Why 2?
Because the diameter is equal to 2 lots of the radius. Okay? Alright, next one. Do we have the diameter or the radius? Okay, so this time I'm using the green formula. So this time I'm going to write C equals what, Madison? Be careful, we've got the diameter this time. You haven't been writing all the notes that I've been writing. You've just been skipping bits. What was the other formula? What does it say here? C equals pi d. What does d stand for? Okay, so what are we going to write here? C equals pi. That's it. It's good. Awesome. Yes?
Or D is like the second part.
No, you don't. No, you can just put centimeters in when it comes to the final answer. So, obviously, if you type that in your calculator, it's going to tell you it's 23 pi to start with, and then we're going to use that ST button and get what, Jade?
So you get 72.2 and since it's given the same round up, so it's going to stay around the same.
Okay.
Why does it go up? It makes it like 3, right?
I don't know. Is that?
It was 17.2.
Okay, so 2 5s came up, so it will go up to 3.
I thought we were doing 3.
We are. That's 3 digits. 1, 2, 3. Remember, you look at the fourth one. Yeah? Remember, you look at the fourth one. Sarah?
I didn't have to go up.
Alright, so here are the final workings for the last thing.
Would you get it wrong on a test if you didn't put the if you didn't round it at the end?
It depends if the question has asked you to round it yet. You're going to have to round it somehow because in the calculator you're not going to write all of those digits.
No. Let's see how it was 100.5. If you just left it like that and it didn't seem around it.
If it didn't tell you how to round it, that would be fine.
Okay.
But as some of you did spot, it was a bit confusing to start with. You saw that these two answers, final two answers were the same. But why was it higher? Why were these two answers the same?
Oh, because 16 plus 16.
Okay, 16 multiplied by 2.
Oh,
Yeah.
this is
So because this was 16 and this was 32, so that's 2 lots of that makes 32. So these are actually exactly the same circle. Yes? That was sneaky, wasn't it?
Yes.
Yes? But it's a good thing to make sure that you appreciate that you get exactly the same answer. If you've got the radius or the diameter, you just need to choose the correct formula. Okay? Awesome.
Another